Hi everyone. Today we will be discussing on partial prestressing. As you all know, the prestressed concrete members are classified into three categories: type 1 members, type 2 members and type 3 members. Type 1 members or fully prestressed members are those members in which no tensile stress is allowed. Only compression is allowed throughout the section. Okay. And in type 2 members, which is also called limited prestressed members, in which some amount of tensile stresses are allowed, but that is below the flexural capacity of the concrete. Okay. That will not cause any cracking. Some small amount of tensile stress is allowed. And in the third type, which is called the partially prestressed members or the type 3 structures, limited tensile stresses are allowed and also with controlled crack widths or the maximum with controls on the maximum width of the crack. So the crack width will be limited and there will be cracks. So tensile stresses is allowed such that there will be some small amount of cracks and the crack width will be within the limit. And this is based on the type of prestressing and the environmental condition. Whether the environmental condition is mild, moderate or severe, or the prestressing is post-tensioning or pre-tensioning or unbounded, like that. For different types of prestressing and different environmental conditions, the width of cracks as well as the maximum amount of tensile stress allowed is different. Okay, and code specifies some values about that one and we'll discuss it later on. Okay, so in general, in partially prestressed members, limited tensile stresses are allowed and some amount of cracks are allowed and the crack width will be within the limit. And the use of partial prestressing was first proposed by M. Berger in 1939 and concept was proposed. For fully prestressed and limited prestressed structures, that is for type 1 and type 2 members, no conventional non-prestressed reinforcement is considered for design. So the conventional reinforcement, that is which is the non-prestressed reinforcement. You know, for RCC structure there may be non-prestressed reinforcements in tensile zone, there may be shear reinforcements etc. provided, and it is not considered for the design purpose. For a fully prestressed and limited prestressed structures, for type 1 and type 2 members, the conventional reinforcements, even though if it is present, it is not considered for the design. Okay. Usually some amount of conventional reinforcement is provided in addition to the prestressing steel. So if it is a prestressed concrete member, so while we discussed the previous sections, only this prestressing steel is considered into the design. The tensile force is taken entirely by the prestressing steel. So even there may be some reinforcing steel which is the conventional reinforcement, which is a non-prestressed reinforcement present in this section, it is not considered for the design purpose. Okay. And when this reinforcement is considered for the flexural capacity, such a section is termed as a partially prestressed section. I hope the concept is clear. So in partially prestressed section, we permit some amount of tensile stress and some amount of cracking, but the crack width will be within the limit. And the main major concept in the design is we are actually considering the conventional reinforcement provided in the cross section for the design purpose. So that will also considered for the design. Usually untensioned reinforcement is required in the cross section of a prestressed member for different reasons, such as to resist differential stringage, temperature effects and handling stresses. So in order to take care of these things, we used to provide additional reinforcements in prestressed concrete structures more than the tension steel. That is a conventional reinforcement or the untensioned reinforcements will be provided usually. And this reinforcement can cater for the serviceability requirements such as the control of cracking and partially for the ultimate limit state of collapse. So that is what I have mentioned in the previous slide. That is, if that reinforcement, that is the untensioned reinforcements or the conventional reinforcements are also taken into account for the design purpose, that type of structure is called a partially prestressed structure. Okay. and which will result in considerable reduction in the costlier high tension steel. Okay, so that will make the structure more economic. Okay, there will be reduction in cost. High tension steel and mild steel have been used as untensioned reinforcement, and usually high yield strength deformed bars or the HYSD bars are used, which is considerably cheaper than the pre-stressing steel, and that will reduce the cost of the construction of pre-stressed concrete structures, and it is more better. The HYSD bars are the surface is deformed, so it will be having higher yield strength and better crack control characteristics because of their surface configuration as compared to the mild steel bars. Okay, so HYSD steels are the commonly used one. So partially prestressed section can either be rectangular or flange section. So in the previous sections also we have discussed about rectangular as well as flanged sections. So here the partially prestressed structures also, it can be in rectangular cross section or flange section, and a section can also be doubly reinforced. So sometimes the section is designed doubly reinforced more than the pre-stressing steel. So reinforcements will be provided both in tension as well as the compression zone, and that is to the compression phase also. Sometimes the conventional reinforcement will be provided only in the tension zone. So it can also be a doubly reinforced section with reinforcement in the compression zone also. Okay, more than the pre-stressing steel. Then we will discuss about advantages of partially pre-stressed section. So the first point is the section is economical, that we have already discussed. Considerable saving in the high tension tensile steel occurs in partially prestressed structural elements. So the saving in prestressing steel contribute to the overall saving in the cost of the structure. So the section is economical. Okay, so that is one of the main advantage of the partially prestressed section. The second is the cambering is less compared to the equivalent section without conventional reinforcement. Cambering is nothing but when we apply the prestressing force. So if you consider cross section, we will be usually providing the prestressing steel below the neutral axis, somewhere here. And if you consider an elevation, pre-stressing force will be applied in this portion. Okay, and when we break the tendon for a pretension case, or when we apply the pre-stressing force, there is a chance for this to bend in this direction, in the upward direction. So that is called cambering. Okay, and cambering is less in case of a partially prestressed section compared to an equivalent section without any conventional reinforcement. If you are providing a prestressed concrete structure without any conventional reinforcement, so that will camber or deflect in the upward direction more than that of a partially prestressed section where the conventional reinforcement is also provided. Okay, fully prestressed members are prone to excessive upward deflections, especially in bridge structures where dead loads from the major portion of the total service loads. Since the dead loads are the major portion of the service load, and there is a chance for excessive upward deflection. Okay, and that can be eliminated in case of a partially prestressed section. The next advantage is the ductility is more in case of a partially prestressed section. If you consider fully prestressed concrete which is having very low ductility, it will produce less alarming time because very small deflection will be there and limited cracking will be there. The cracks may not be visible, it will not crack, and the failure is brittle. And in case of a partially prestressed section, the ductility of the section will be more since we provide conventional reinforcement too. And then the next point is fully prestressed members, due to their higher rigidity, they have lower energy absorption capacity compared to the partially prestressed members which exhibit ductile behavior. So the energy absorption capacity of a partially prestressed member is more. And the next point is the reversal of moments. For example, if there an earthquake occurs, which is in the case of a partially reinforced section or partially prestressed section, if there is reversal of moment occur, this is not detrimental as compared to an equivalent section without conventional reinforcement. So these are the advantages of a partially prestressed section. So we have discussed the section is economical, the cambering is less, then ductility is more in case of a partially prestressed section, then the partially prestressed section having higher energy absorption capacity, and it can cater for the reversal of moments. And in such cases it is not much detrimental compared to the equivalent section without conventional reinforcement.
Computation of width of crack. The crack width computation is having much importance in case of type 3 members. Okay, so for type 1 and type 2 members there will not be any cracking, and this limit state of serviceability for cracking is not much important in case of a type 1 and type 2 members, and it is having importance only in case of type 3 members, that is a partially prestressed concrete. Okay, then width of crack is primarily depends upon the stress in the reinforcement, and it is also influenced by the cover and type of the reinforcement, how much clear cover that we are providing, and the type of reinforcement used in the section. So these are the factors, main important factors which affects the width of cracks. Then several empirical relations have been developed to estimate the width of cracks. The methods proposed for crack width calculation is mainly divided into two categories, and the first one is calculation of crack width based on the stress in the reinforcement. Okay, and it is obtained by the conventional theory of cracked reinforced concrete section, and the second one is calculation based on the fictitious tensile stress in an uncracked section, and the first one, which is based on the stress in the reinforcement, is more accurate than the second one. And IS 456-2000 Annex F gives a procedure to determine the flexural crack width, and it is based on the first method, calculation of stress in the reinforcement from the conventional theory. Okay, and there is a formula for the crack width computation in Annex F. You may have studied in your previous semesters, and I am not going into detail of that one. And you can compute the width of cracks based on that formula for the prestressed concrete structures also. And limits of crack width according to IS 1343-2012 for design of type 3 members, the following may be regarded as a reasonable limits. The surface width of cracks should not in general exceed 0.1 mm for members exposed to particularly aggressive environment, which is such as severe category, and not exceeding 0.2 mm for all other members. So the maximum limit of crack width is limited to 0.1 mm for severe condition and 0.2 mm for all other conditions. So this is a clause in IS 1343 regarding the limit state of serviceability, that is cracking. And cracking of concrete shall not affect the appearance or durability of the structure. So this is the main criteria. It should not affect the appearance and durability of the structure. And criteria of limit state of cracking for the three types of prestressed concrete members shall be as follows. For type 1 members, this is we have already discussed, there is no tensile stress. For type 2 members, tensile stresses are allowed but no visible cracking. But for type 3 members, cracking is allowed, and it should not affect the appearance or the durability of the structure. As a note, this is we have discussed in the previous slide, it is mentioned that the maximum width of crack is 0.1 mm for severe condition and 0.2 mm for all other members. Next is design of partially prestressed sections. The final design of any prestressed concrete structure involves the checking of stresses in concrete at transfer as well as under service loads. Okay, with respect to the allowable stresses. So in whether it is type 1, type 2 or type 3 structures, we have to check the stresses in concrete at transfer and under service load at the top and bottom with respect to the allowable. Allowable stress depend upon the type of member, whether it is type 1, type 2 or type 3 member. Okay, for type 1 members, no tensile stresses are allowed. For type 2 members, some small amount of tensile stresses are allowed. Around 3 Newton per mm square tensile stresses are allowed, and if it is temporary loading, additional 1.5. A maximum of 4.5 Newton per mm square is allowed for type 2 members. And for type 3 members, a hypothetical tensile stress, which is given in table number 10 of IS 1343 that we'll discuss later, is the allowable stress limit. Okay. And the design steps for type 3 members is similar to that of type 2 members only, and difference is being in the value of allowable tensile stress in the concrete. So this is the clause regarding type 3 members in IS 1343 2012. This is in page number 36, clause 26.4.2. Type 3 members in which cracking is permitted, it may be assumed that the concrete section is uncracked and the hypothetical tensile stresses exist at the maximum size of cracks. Table 10 gives the value of hypothetical flexural tensile stress for the type 3 members. The values are given for different types of tendons and different limiting crack width criteria for each tendon for 0.1 mm. So we have discussed in the previous slides that the limiting crack width is 0.1 for the severe condition and 0.2 for other conditions. So for each condition, the values of hypothetical tensile stress for different grades of concrete is given in this table number 10. And as a note, it is mentioned that when additional reinforcement is distributed in the tension zone, for every 1% additional reinforcement, the hypothetical tensile stress can be increased by 4 Newton per mm square for these two categories, pre-tension tendons and grouted post-tension tendons. It can be increased by 3 Newton per mm square for other members, for the third category members. So you can obtain the value of hypothetical flexural tensile stress for the type 3 members from this table, and it should be modified by coefficients obtained from figure 6. In figure 6, which depends upon the depth of member, so for 400 mm depth, the depth factor is 1, and for less than 400, you can obtain values from here, and for more than 400, you can the values will be less than 1. Okay, you can multiply the values obtained from this figure 6 to the values obtained from table 10, and we can obtain the value of the hypothetical tensile stress. So that is how we obtain the allowable tensile stresses in concrete in case of type 3 members. Now the potential applications of partially prestressed concrete. It is used in many areas and I have listed some of them. Important structures in which this partially prestressed concrete is applied are the cast in place structures in general, then pier cap, footing, pier column, then transverse design of box girder, precast girder with large camber, arch bridge, etc.